Hello everyone, I welcome you all in this course Engineering Drawing 1. Today we will discuss engineering drawing and sketching. What is the content of engineering drawing 1 which is we are going to discuss is in this video. Okay, the first one is isometric drawing, multiple views drawing, dimensioning, sketching, drawing tools, assembly drawing, cross-sectional views, half section, section of object with hole, rivets and etc. More dimensioning, where to put dimensions. What is the introduction of engineering drawing 1? One of the best way to communicate one's idea is through some form of pictures or drawing. This is especially true for the engineer. The purpose of this course is to give you the basis of engineering sketching and drawing. We will treat sketching and drawing as one. Sketching generally means freehand drawing. Drawing usually means using drawing instrument from compass to computer to bring precious to the drawing. This is just an introduction. Don't worry about understanding every detail right now. Just get a general feel for the language of graphics. We hope you like the object in figure 1 because you will be seeing a lot of it. Before we get started on any technical drawing, let's get a good look at this strange block from the several angle. That is the very good example is given. That is mechanic block. The example is in this figure is given. Okay, now we will discuss is isometric drawing. The representation of the object in figure 2 is called an isometric drawing. This is one of a family of three-dimensional view called pictorial drawing. In an isometric drawing, the objective vertical line are drawn vertically and the horizontal line in the width and the depth plane are shown at 30° to the horizontal. With drawn under these guidelines, the lines parallel to these three axes at their true scale length. Lines that are not parallel to these axes will not be of their true length. Any engineering drawing should show everything. A complete understanding of the object should be possible from the drawing. If the isometric drawing can show all detail and all dimension on one drawing, it is ideal. One can pick a great deal of information into an isometric drawing. However, if the object in figure 2, which I will show you in the coming slide, had a hole on the back side, it wouldn't be visible using a single isometric drawing. In order to get a more complete view of the object, an orthographic projection may be used. That is the figure 2, which I explain it. Let's move on. Orthographic or multiviews drawing. Imagine that you have an object suspended by the transparent threads inside a glass box as in figure 3. You can see it in figure 3. Then draw the object on each of three faces as seen from that direction. Unfold it the box in figure 4. I will show it, and you will have the three views. We call this an orthographic or multiviews drawing. You can see it in figure 4 and figure 5. We cut it. We are showing here the front view is it this side, that is the front view of the box, and the side view this one, and the top view is this one. Let's move on. Which view should one choose for a multi-view drawing? The view that reveals every detail about the object. Three views are not always necessary. We need only as many views as are required to describe the object fully. For example, some objects need only 2 views, while others need 4. The circular object in figure 6, I will show it, require only 2 views. In this object, only required 2 views. In figure 4. Okay, dimensioning. We have dimensioned the object in the isometric drawing in figure 7, which I will show you, which is going to show you. As a general guideline to dimensioning, try to think that you would make an object and dimensions it in the most useful way. Put in the exactly as many dimensions as are necessary for the craftsman to make it, no more, no less. Do not put in the redundant dimension. Not only will these clutter the drawing, but if tolerance or accuracy level have been included, the redundant dimensions often lead to conflicts when the tolerance allowance can be added in the different ways. You can see it in the figure 7 and isometric view with dimensions. Okay, repeatedly measuring from one point to another will lead to increases. It is often better to measure from one end to various points. This gives the dimensions a reference standard. It is helpful to choose the placement of the dimension in the order in which a machinist would create the part. This vocational may take some experience. Okay, let's move on the sketching. There are many times when the interior detail of the object cannot be seen from the outside. In figure 4, I will show it. Okay, that is the figure 4. No, that is the figure 8. Outside of, from the outside. We can get around this by presenting to cut the object on a plane and showing these sectional views. The sectional views is applicable to objects like engine block, where the interior details are intricate and would be very difficult to understand through the use of hidden line. Hidden lines are by convection or dotted on a orthographic or isometric drawing. Imagine slicing the object in the middle, figure 9. Look, we are cutting this one object with some kind of use the device to cut this object into two parts. And then when we are do this when we did this sectioning, when we cut it, when we divide it one object into two pieces, then you can see it in figure 10, sectioning the object in figure 8, that is coming from figure 8. Okay, now in the figure 10, sectioning isometric and orthogonal views. The cross section looks like in figure 11 when it is viewed from straight ahead. You can see it here in figure 11 when we cut the one object, then you can see it, that is the sectioning view. We have to show them. Where is the cutting side, we need to show that is the sectioning view. We need to show them. Okay, drawing tool. To prepare a drawing, one can use manual drafting instrument in figure 12 or computer aided drafting or design or AutoCAD. I will show you in figure 12. That is the figure 12. That is the manual drafting instrument. You need T-square, set square, compass and other all kind of stuff. The basic drawing standard and conventions are the same regardless of what design tool you use to make the drawing. In learning drafting, we will approach it from the perspective of manual drafting. If the drawing is made without either instrument or AutoCAD or we can say CAD, it is called a freehand sketching. Okay, belong to drawing tools. I have already prepared the online video. For more description, please you can visit. I will upload on the description or on the Zoom account. You can click it. You can see it in properly. I made it for our engineering drawing tool a separate video. Please go and visit for more description, then you can understand what kind of engineering tools we need to use it. Okay, assembly drawings. An isometric view of an assembled pillow block bearing system is shown in figure 13. You can see it. It corresponded closely to what you actually see when viewing the object from a particular angle. We cannot tell what the inside of the part looks like from this view in figure 13. Okay. In figure 14, we can also show isometric view of the pillow block being taken apart or disassembled in figure 14. You can see it. This allows you to see the inner component of the bearing system. Isometric drawing can show overall arrangement clearly but not the detail and the dimensions. Okay, the next is cross-sectional views. A cross-sectional view portrays a cut-away portion of the object and is another way to show hidden component in a device. Imagine a plane that cut vertically through the center of the pillow bag as shown in figure 15. Then imagine removing the material from the front of this plane as shown in figure 16. You can see it here. This is how the remaining rear section would look. Diagonal lines, cross-sectional hatching. That is the cross-sectional hatching. Show regions where material have been cut by the cutting plane. In figure 17, this cross-sectional view section AA, figure 17, one that is orthogonal to the view direction. Show the relationship of length and diameters better. These drawings are easily to make than isometric drawing. Second, engineers can interrupt orthographical drawing without need an isometric drawing, but this takes a bit of practice. In figure 18, the top outside view of the bearing is shown in figure 18. It is an orthogonal perpendicular projection. Please notice here the direction of the arrow for the AA cutting plane. Let's move on. Half sections. A half section is a view of an object showing half of the view in section, as in figure 19 and 20 shown. The diagonal lines on the section drawing are used to indicate the area that has been theoretically cut. These lines are called section line or cross hatching lines. The lines are thin and are usually drawn at a 45-degree angle to the major outline of the object. The spacing between the lines should be uniform. A second rare use of cross-hatching is to indicate the material of the object. One form of cross-section hatching may be used for cast iron, another for bronze, and so forth. More usually, the type of material is indicated elsewhere on the drawing. Making these of different type of cross-sectional hatching is necessary. You can see in figure 20, front view and half section. Okay, in figure 21, half section without hidden lines. Usually hidden lines or dotted lines are not used on the cross section unless they are needed for dimensioning process. Also, some hidden lines on the non-cross sectional part of the drawing are not needed in figure 12, which is shown in previous slide, since they become redundant information and may clutter the drawing. Sketching object with hole, rivets, and etc. The cross section on the right of figure 22 is technically corrected. However, the convention is a drawing is to show the view on the left. You can see it, view on the left. This one is corrected as the perfect method for the sketching this type of object. Please be careful. Don't sectioning into in this, which is in right side of the figure. Do this in left side of the figure, that is the cross sectional. Sketching, that is the sketching views, sketching object, sketching cross sectional side. Let's move on. Dimensioning. The purpose of dimensioning is to provide a clear and complete description of an object. A complete set of dimensions will permit only one interruption needed to construct the part. Dimensioning should allow this guideline. Number 1. Accuracy. Correct value must be given. Number 2. Clearance. Dimensions must be placed in appropriate position. Number 3. Completeness. Nothing must be left out and nothing duplicated. Number 4. Readability. The appropriate line quality must be used for legibility. Next, move on. The basis, definitions and dimensions. The dimensions line is a thin line broken in the middle to allow the placement of the dimensions value with arrowhead at each end. In figure 23 I will show you here, you can see it here. Dimensioning drawing. Okay, an arrowhead is appropriately 3 millimeter long and that one arrow, and the 1 millimeter wide, that is the length is roughly 3 times the width. Extension line. Extend a line on the object to the dimension lines. The first dimension line should be appropriately 12 millimeter and this one is inch 0.6 from the object. Extension line being 1.5 millimeter from the object and extend 3 millimeter from the last dimension line. A leader is a thin line used to connect a dimension with a particular area. You can see in figure 24. Example drawing with a leader is given. A leader may also be used to indicate a note or comment about a specific area. When there is limited space, a heavy block dot may be substitute for the arrow, as in figure 23. You can see it in figure 23. Also in this drawing, two holes are identical along the two axes. Notation to be used and the dimension to point to only one of the circle. Where to put dimensions? The dimension should be placed on the face that describe the feature most clearly. Example of appropriate and inappropriate placing of dimensions are shown in figure 25. You can see it here. The next in figure 26, that is the simple object. In order to get the feel of what dimensioning is all about, We can start with a simple rectangular block. With this simple object, only 3 dimensions are needed to describe it completely. In figure 26 you can see it. There is little choose on where to put the dimensions. It's came the figure 27 surface datum example. We have to make some choice when we dimensions a block with a notch are out cut out in figure 27. You can see it. Okay, it is usually best to dimension from a common line or surface. This can be called the datum lines of surface. This eliminates the addition of measurement or machining increases that would come from chain or series dimensioning. Notes how the dimensions are granite on the datum surface. Please note here. Let's move on. In figure 28, surface datum example is given. In figure 29, we have shown a hole that we have chosen to dimensions on the left side of the object. The theta standard for diameter. You can see it, that is the standard diameter. We need to mention them. If is it inside there is a hole, we have to tell them the diameter. Here is given one example. In figure 13, example of directly dimensioned hole. When the left side of the block is radius is in figure 13, we break over rules that we should not duplicate dimensions. The total length is known because the radius of the curve on the left side is given. Then for clearly we add the overall length of 60 and we note that it is a reference dimension. This means that it is not only really required. Let's move on. Somewhere on the paper, usually the bottom, there should be placed information on what measuring system is being used. For instance, inch or millimeter. Also the scale of the drawing. You can see it in figure 31, example of a direct dimensioned hole. This drawing is symmetric about the horizontal center line. Center line, chain, dotted line, you can see it, are used for systematic object and also for the center of circles and hole. We can dimensions directly to the center line as in figure 31. In some cases, this method can be clearly than just dimensioning between circles.